All right, so in the next episode, we got Rob here, and I met Rob on LinkedIn because of a lot of his insightful, rather feedback on my posts, and he has schooled me a few times, which I appreciate. A few of your countering stances, which I really enjoy about that platform. It really gets a lot of varying perspectives out on the table and allows us to have sort of a healthy discord back and forth. So first of all, thank you for your involvement and thank you for hopping on today.
Yeah, no problem. Glad to be here.
So for anybody that doesn't know, a lot of Rob's time, I don't want to speak for you, but was spent at RDH, which my direct exposure has not been a lot, but what I've seen from the industry is RDH really kind of focuses on sort of building science principles from the basics at its core. And they don't fancy themselves as, fancy facade consultants. It's really, honing in on the technical. So it'll be good for everybody to understand a little bit of kind of your experience. And when I say that, obviously in facades, but, what areas in terms of new versus existing buildings, and then what type of systems you really feel comfortable diving into.
Yeah, well, prior to my time at RDH, I spent a good amount of time in Boston at SGH2, and the two companies between the two, I spent a lot of time both investigating buildings and traveling around figuring out how buildings fail and then prescribing how to fix them and kind of seeing through those repairs for all aspects: waterproofing, roofing, facades, masonry, you name it. And, then a lot of my time as I transitioned to RDH was spent helping architects, developers, contractors leverage that knowledge of how things fall apart or how they fail and applying that to new construction. So I did a ton of new construction, both, sort of mid-rise wood framed over 2 levels of parking garage to high-rise glass towers all over the Seattle, sort of Portland landscape, so to speak, as they tried to migrate that urbanization of bringing people downtown. And so I spent, a lot of my time bouncing between existing buildings and new buildings. And then I found myself in the forensic expert kind of chair a lot, doing a lot of expert testimony of truly figuring out how buildings fail and then trying to figure out how things sort of got there, and then trying to use that knowledge to help people stay out of trouble and help people build better buildings. So yeah, that's my background in a nutshell.
I'm happy to. We spoke about this before. I'm sorry I didn't bring up the time at SGH, and that's a really good talking point, because I actually had a couple of the SGH folks on from the Boston office, which I spent a lot of time up there, and between there's a lot of recurring themes on this podcast, and it's really discerning some of the more progressive code-driven markets versus when you start bleeding into the Midwest or secondary markets where a lot of these codes aren't heavily enforced. But I mean, in Boston, what we're seeing right now is one of the most stringent energy codes in the country, and everybody's sort of being in a little bit of a reactive position. But that's nothing new to Seattle. Were you involved in kind of any of those energy code discussions and seeing sort of how the market reacted as a whole?
Yeah. When you mentioned that Boston's got the most stringent, I kind of chuckled a little bit, because for a long time, Seattle was the one that was the sort of the leading the way and the most stringent. And it's kind of funny because it's not that harsh of a climate in many respects, right? But they were sort of pretty aggressive at pushing a lot of things. And, it's fear. A lot of people get scared because the uncertainty of what that represents, right? People start getting used to one thing. They start developing expertise, knowledge, they kind of figure it out, they start feeling comfortable, and all of a sudden you feel like the carpet's being pulled out underneath you because now we got to do things differently. So I've gone through a lot of those changes, and, I was often on the phone with the director at the city of Seattle saying, hey, Rob, what are your thoughts on this? And can you come in and talk to the developers to talk them off the ledge and help them understand that this is not going to be that big a deal? And the first wave was really about, extra insulation in the wall, really. I remember having to figure out how to do a hybrid wall assembly where you've got steel studs with insulation and a bunch of insulation outboard, because you really needed both to kind of get there without getting these exterior insulation walls overly thick. And that was just the first task. And one of the biggest challenges there was actually figuring out how to manage water in that assembly and what kind of vapor permeability and air permeability those membranes needed. And that was where people like me that have that background training in building science, it was not scary. It was just a math problem, so to speak, or drawing upon past experience. And coming from Canada too, so my original undergrad education is out of Canada, and learning all these building science fundamentals. Canada's got a fairly stringent code altogether, right? So then coming down to the US and doing grad school down here, a lot of that stuff didn't seem that foreign, and it was just kind of helping people through understanding how it works and that this has been done before, and it's totally possible. And then the second wave of energy code changes was this whole notion of testing the building air tightness at the whole building level, which got people sort of just completely up in arms, and they were all worried about this number that was sort of intangible to a lot of people. And
they're like, we don't need to just get it right on paper, we actually have to execute it.
Yeah, exactly. And I can understand, right? Because, the hair on the back of people's necks starts standing up because they start worrying about getting sued, or what happens when we don't get there. And, again, we drew upon a lot of our expertise coming out of school, and a lot of the research that had been done, and bringing that forth and talking to the director at the City of Seattle Energy Department and saying, yeah, no, we can do a little study here to help people over the hurdle here. And a lot of our developer clients at the time that I was working with, we're worried about this air barrier requirement. And I said, hey, here's a little secret. I've been doing this to your buildings the whole time because it's important, right? I wanted your buildings to work really well.
Sure.
So it's not something new. The only difference in cost for you is going to be the cost of the test at the end, right? Which in the grand scheme of things was not a huge number compared to the total cost of the development. So, we did a bunch of studies and existing buildings that were starting to be built, and doing some incremental testing, and doing some testing on some assemblies and some lab environments and things of that sort. And really, I don't think we ever had a building that failed to test. We started getting more and more stringent, and the assemblies, and we figured out where the hot spots were and what to focus on, and it really wasn't that difficult in the grand scheme of things.
You use the word fear, and is there a fear or reluctance from a liability standpoint, overlooking something, missing something, and having it come back to you as a licensed professional or as the delegated designer, or is it? And I kind of want to differentiate the two between like fear of missing things during the design standpoint versus actually making a mistake in terms of the as-built condition, meaning you can hit your NFRC targets and you can hit your U-value targets, but if you have condensation all around the window frame, your developer is going to say, what the heck did you detail here?
Yeah, no, well, it's interesting question. There is always some level of fear, and depending on the type of building, that level of fear is, escalated, say, for example, in condominiums, right? It's not a matter of if you're going to get sued, it's when you're going to get sued kind of thing. Yep. But the benefit that I never really had that fear, because I had what I'll call the luxury of spending a lot of time getting to figure buildings out and how they failed, and really the underlying things that were important. And it's funny that you bring up the NFRC and the U-value thing, because 25 years ago, Sean O'Brien at SGH in New York and I were talking about the fact that you can have all these great numbers and this high performing assembly, but how you install it in the wall matters, and how the mechanical system is interacting with this glazing system matters. And I can take a crappy window, a crappy U-value, crappy condensation resistance window, and have no condensation on it, just in how I install it, where I put it within the wall assembly, and how much hot air I blow over it, right? And I mean,
but you and I have had this discussion, though, and this is where it gets challenging, because I was on the consulting side and now I'm on the contracting side, and the question becomes, am I trying to give you something that's going to hit your code target or code value, or something that's actually going to work? And I'm not going to name names, but I've asked consultants before, or whoever was asking, and I was like, do you want the real U value or this prescribed U value that I'm going to use some manipulated formula to get you the value that's going to hit your target?
100%. And it's these things that I would bring to the table as a consultant, saying, look, there's two things here. There's the code check and there's the actual performance. And at the end of the day, I want to help you with both, right? Because we can't avoid the code. You got to check the box. You got to go through the motions. But what I'm really here to help you is to avoid the problems within an expectation of what kind of performance level within certain, restrictions, if you will. But, you get into an indoor humidified natatorium in a cold climate, and there's no code information in there on how to avoid condensation on a curtain wall system, right?
Sure.
And you're trying to get the mechanical designer to understand what your challenges are, and you're trying to speak the same language. And at the end of the day, it's about avoiding that condensation up to a minus 20-degree temperature, right? Because we can't work miracles if we're going to get down to minus 50 or minus 60. I mean, we just have to accept that in some instances this condensation is going to form, but it's going to be in this very narrow band for this very sliver of time. So there's the dual fear, but again, I draw upon all that forensic experience of trying to figure out how buildings really work, where the gaps in the design community are, where the gaps are in the code, and things that we can do to kind of fill those gaps that are not obvious to maybe the average practitioner, because I draw upon the forensic experience, right? Like the energy codes now is just full of all sorts of stuff that's going to create a whole bunch of new failures. And I've already been seeing that for the last 10 years or so, right? High performance thermal spacers, all sorts of stuff that's going to be driven by energy code that people are going to not realize that the non-metal spacer is going to off gas some volatile organic compounds. And then you're going to get condensation in the glass, but it's not even water vapor. It's some gas that was off gassed. And you're like, oh my gosh, who would have thought?
These conversations you're having today look different than when you were practicing at an RDH or SGH, meaning now you're hired. And I don't know if you're building out your firm. We could talk a little bit about that. But if you have some of, how those conversations look in terms of the end user, who you're working with, if you were working with a certain type of clientele before, now you're working with a certain type after, who might be, maybe they're hiring you because they actually want to hear what you have to say versus, in the past, maybe they're hiring because that person is just going to do what I say.
Yeah. Well, I guess one of the things I would pride myself in my career is I kind of figured out a way to work for the people that actually wanted to hear what I had to say and actually wanted to do what I did. And you know what? It's funny because a lot of those individuals had to go through that meat grinder of experiencing something that wasn't particularly pleasant, right? Getting sued because they didn't pay enough attention here, or they didn't want to pay you to do site inspections or plant inspections. And it's like, look, this could have been avoided by this, right? And it would have cost $40,000, and now we're dealing with a $4 million or a $10 million problem, right? These could have been circumvented by having the right people involved in the projects at the right time. And I tried to filter through the client base, and the ones that I enjoyed working with the most were the ones that saw the value in what you had to offer, and the expertise that you brought to the table, and how you could solve problems, and how you're a team player. And those are the clients that I tended to navigate towards, and really wanted to do an exceptional job. And I was very fortunate in my time at both SGH and RDH getting to work with some really top level clients.
I want to share this story, and I'm sure you'll have something to say about it. A lot of my early career was spent on high-rise unitized curtain wall, and you think you get you onboard the team, and you have sort of a more experienced inspector doing the early inspections, making sure they're setting the starter seal right, the units are going in, you're getting your chicken head seal and your stack joint seal going, and everything's working, and you pass the first few flood tests or gutter tests, and so you're okay. So now rinse and repeat for 30 floors. But it's like, all of a sudden now we're on floor 26, 27, 28, and that quality is starting to diminish. Or you go back to that hoist run leave out, and all of a sudden maybe they don't have budget anymore to send the inspector out, and that's always where your problem areas are. So where I first witnessed this is I was in a high-rise building. It was a major curtain wall contractor, I'm sure you know, and the awnings didn't properly work. Couldn't open them, and then when you open them, they slam shut. sure you've seen that time and time again because of the wind. And so I'm thinking to myself, is this a whole building issue? And the guy I was with said, no, we're on the 27th floor. You think the inspector was out here by this late stage in the construction actually doing the punch list work or checking the ADA compliance, the operability? And so it's like, do you see this diminishing quality as the construction CA phase starts to pan out? And then does it end up just catching up to you in the end?
Yeah, absolutely. I mean, and it's funny, it's you often run, you often get relatively young, inexperienced inspectors on site. And there's a whole construction dynamic of a bunch of people that have worked their entire lives. I've been doing this for 30 years, and they got forearms the size of your head, and they're kind of scaring the bejesus out of your pencil pushing engineering, and it's a rough go. And it's funny because I learned this lesson, on one of my favorite jobs of all time was the Christian Science Publishing House in Boston, working for SGH. And I got the fun job of inspecting the reglazing of all the bronze windows there. And we're talking double hung, 6 foot wide, 12 foot tall. I'll never forget, true divided lights. And they had a wet seal
chain to open it up.
Absolutely. And and I remember, inspecting the glazing because the bead had to be a certain size, had to have a certain bite, a certain profile. And, I was marking the ones that needed to be redone, right? And the glazers were just out of their minds. Like, why are you being so anal? And I'm like, I think you guys are doing a great job. You got like 98%. Like, it's only 2% failure, but you're focusing on the 2%. And, I just realized that if I could work with them and help them see that I was there to be part of the ultimate success of the project and make their, I don't want to say lives easier, but at the same time, be respectful of them and help them realize that we were actually on the same team, so to speak. It smoothed things out pretty quickly, but, I'm a mid-20 something engineer with not a ton of experience. And, Boston is a great spot to get your first taste of construction site experience, I would say. I'm sure New York, Philadelphia are probably very similar in many respects. But yeah, you gotta get through it, and you gotta figure out how to plan your budget so you can get to the inspections at the top floor. And there has to be a senior person who's helping the client see, like, this is important. We can't just inspect the first couple of floors, right? We got to see this through the end. We got to hold them accountable up to the end, and we got to make sure that it's all sort of getting done, and all the T's are crossed and the I's are dotted.
That's where it gets. And just to speak frankly, I think this is an industry-wide challenge. You have the client relationship. They hire you, they hire the firm you're along with, and maybe you go out there and you do the first visit with him, or you explain, this is what we're looking at, this is why our inspector is here, and understand the ramifications of some of these mistakes. But then for the client to actually feel like or actualize that they're getting that level of service, when you have to have an entry-level inspector out there doing all these inspections. And with some of the inspections, torquing the anchors at the P-clip, there's life safety implications along with it. Checking for your fire safing, I mean, all these things. And unfortunately, I don't know if we're at a place where there's a level of comfort that some of the contractors can be trusted to have that own QA QC internal protocol, ongoing throughout the project. Some are better than others, but I don't think this is a market specific issue. I think this is industry wide.
It is. And I would say that where I've seen great success with some contractors is the ones that have kind of embraced the importance of, well, I mean, my world is the enclosure, right? So it's the ones that have embraced it and recognize the importance of bringing somebody on internally that can kind of lead the review of the drawings, the understanding of the sequencing, the understanding of, okay, this is what was originally spec'd, but now we're going to use this, and how does that trickle through? And what about the the curing compounds on the concrete? Is that going to be adverse to this waterproofing that we've chosen to use because of the time of year that we're going to be building, which is more amenable to the winter climate as opposed to what was originally specified? And somebody who's working on the internal side that then can use someone like me to the greatest extent possible. And they can also help see through that internal QA QC process for the contractor, right? That's where I think that there's a lot of missed opportunity, and that some contractors just don't hire that internal person to kind of stick handle and coordinate, and maybe even be an enclosure superintendent who's just recognizing how all these parts and pieces need to come together, how waterproofings need to get integrated into glazing systems, and how glazing systems transition into roof systems, and when are all these people going to be on site, and who are the right people to have in the coordination meeting, et cetera, et cetera. And that internal resource, I think, can save a lot of headache, a lot of problems down the road, but also during construction. And I think that that's where maybe some of the mid-level contractors out there really need to step up and get to that next level. And some of the more successful ones are the ones that have adopted that mindset, 10, 15 years ago.
I think for a general contractor or CM to have facade superintendents or specialists is becoming more commonplace. And obviously the facade enclosure industry consulting side is gaining more and more traction in certain markets. Do you find that architects are embracing the enclosure more, and you're finding more and more firms having in-house specialists, or is the idea that more and more of them are delegating that to their facade consultant?
I've seen a bit of a mix. I would say that the larger firms definitely have more savvy enclosure experienced people in-house, and they're usually just really good experienced technical architects that have a thirst for knowledge, and they've just wanted to develop a knowledge base in the technical aspects of the enclosure. The smaller ones, I would say, tend to still rely heavily on their enclosure consultants in entirely, just because they have to. They don't have the ability to kind of justify a person where they might be a 10 or 20 or 30 person shop. So the larger ones definitely. But I would also say that some have taken the approach of just having a pretty seasoned, experienced architect as a senior QA person. And those QA people really recognize the importance of having good consultants on the team and coordinating and documenting what those consultants bring to the table. And they can do a good job of vetting consultants from some sort of ones that are actually truly have the experience versus ones that maybe aren't quite there yet.
Do you think this is a good industry to enter into if you're a young professional or if you're somebody in school?
You know what? I have my energy level and excitement about this industry has not waned since 26, 7 years ago. I think it's fascinating. I think that there is so much technology to learn that there is no end to the amount that you can learn every day. So if you like to do something different, sort of week to week or month to month or year to year, and dive deep into, the technology of glass, the technology of roofing, the technology of just holistic building performance, I think it's a fantastic industry because it's dynamic, it's ever changing. I always love the fact that you got to spend a lot of time in the field. For the sort of the last few years of my time at RDH, that was the thing that I missed the most, is being in the field, being in the architect's office, being in the general contractor's office, troubleshooting problems, seeing things come together, and sharing, just a career's worth of knowledge with the next generation of engineers that want to learn this stuff. And it's not, and what's interesting is that there's even just so much more beyond just the technical, right? Because now it's okay, you're the smartest person in the room, right? You got all this knowledge, but how do you not piss off, for lack of a better term, the architect, the contractor, the subcontractors, right? And learn that ability to be a team player and collaborative, and soak in all of their knowledge and what they know and what the world looks like from their perspective. That's just an ongoing challenge, and I just love that, and that's just fascinating to me. And that at the end of the day, when you're driving through the city and you can point out to your kids or your spouse or your family, hey, I worked on that building and I remember these problems and we had to figure that out, and it was really cool, right? It was a bit of a headache, it was kind of stressful, but at the end of the day we came out on top. And there's a lot of pride in that, and you get to touch a lot of buildings, and you get to say that you made a difference on stuff. So I think it's a fantastic industry, and I would absolutely encourage young, technical, aspiring people to get involved.
It's really funny that you said you miss that time in the field, because I remember all of my time in the field or in the shop, all I wanted to do was be in the office and do the consulting work and do the early work. And so it's always, this game of the
Grass is
grass
always
is
greener.
always greener, of course, of course.
Yeah.
And I think I was fortunate. I don't know if I think we go through seasons of life where you experience different things at different stages. And so in the moment, I didn't appreciate it, but now I can reflect and appreciate my time on the consulting side all that time in the field, because you could take that over into your next journey on the contracting side or manufacturing. I get it now. And now I can speak with the consultants and understand their concerns, the way they're looking at the drawings, the way they're looking at the assembly. Have you seen anybody on the flip side come from the contracting side to the consulting side? And do you think if you don't have that holistic experience, it limits your outlook, or you just have to be aware of it and to be more well-rounded?
I think that there's absolutely opportunity, and we did this pretty successfully in my career with bringing people that have non-traditional experience, we'll call it, right? There is no there's no way that you wouldn't benefit from somebody who's actually worked with their hands on the contracting side, because they have a level of knowledge and appreciation for challenges that people that have only sort of observed just don't have, right? It's just it's if you can appreciate what they bring to the table, and you can be collaborative and bring a team of people together that are actually similar but dissimilar, right? That come from different perspectives. That just adds a whole nother level, right? Because my initial degree was structural engineering, right? I was going to be a structural engineer, and then I took this course called building science, and my head exploded. I was like, oh man, this is what I want to do, right? And to sit in meetings where I'm working with enclosure consultants that maybe didn't come from a structural background. They came from a mechanical background, right? And they have a different appreciation, understanding, and a lens to look through, or an enclosure
Or
consultant.
design, architectural
Yeah,
background.
or exactly. I was going to say an architect who comes at it from another perspective, and then somebody who came through the trades who's got just yet another perspective, right? And it's or from the manufacturing side and understanding the challenges with dyes and understanding the challenges with sourcing aluminum, and somebody who kind of appreciates the procurement side of things and the sort of the long lead time of things. And this stuff just can't show up tomorrow because you decided that that's what you want. That's what makes a team strong, is somebody who comes at it from all these different perspectives to kind of cover all the bases. So absolutely, I think people who come from a contracting background, waterproofing, glazing perspective, can be highly successful consultants.
Agreed. Okay, so let's change direction a little bit. Imagine if I was at SGH or RDH, you would probably have your office locked to me, because I'd be picking your brain all the time and calling you all the time, because I think someone like you is a wealth of knowledge. And it's so, that I think that's a problem at a lot of firms. You have a few people who hold, I don't know, outsized amount of the knowledge. And so if you're early on, sort of, if you were to reflect, what were some of the best sort of learning opportunities for you? You said in the field. How about experience being in the shops, or even like PMU testing? What you were to gain from some experiences like that?
Oh, absolutely. Any situation that puts you in a position of having to think on your feet, right? Like, you can't fake it when you're sitting there at a PMU, and you got to know the stuff inside out, right? Not only do you got to know the standards, you got to know the testing protocols, you got to know all the little things that they're going to try to do to pull the wool over your eyes. You got to know what you're actually trying to accomplish from a big picture standpoint, so you can make, decisions on the fly about how we might do something different. And that comes from experience. I mean, the PMU's fantastic. I can't tell you how many times um, I would get a lot of young engineers complaining about doing water testing, right? And it's like, I know that you got all these degrees, you got all these letters after your last name, but doing stuff with your own hands and going through the motions and figuring stuff out when it doesn't go according to plan is completely, it's amazing how empowering that is. I can go back to my buddy Francesco Spagna from SGH, and we were testing somewhere in New Jersey, in the Magna Helic, the thing that measures the pressure differential across the chamber, either didn't get packed in the equipment or it didn't work or whatever. And we had to, get a tube with water and, measure head of water and, using our engineering background to figure out how to solve a problem in the moment.
Yep.
Because we were like, now what are we going to do? Right. We can't go back to Boston and say we didn't accomplish the test, because they would have raked us over the coals. We're
Yep.
sitting there in New Jersey and time's ticking and we got to get it done. So it's those kinds of things that you have to help the younger people see the benefit and the importance of that experience. And I had a lot of really good mentors at SGH right out of the gate, like when I was coming out of grad work, who kind of said, hey, you know what, you think you know a little too much, you need to kind of go back here and kind of get back to basics here. And you know what, I had a lot of those aha moments, and I reflect on them, and I try to share those stories with young people as much as possible. And when you see those light bulbs go off of, you know what, this is actually benefiting me, and I don't fully appreciate why yet, but I'm going to trust the process. That's incredible when you can kind of see people benefit from that and grow from that, and then build upon that, and then follow them along into their consulting career.
Some of I'm sure the basics will laugh over some of the things you think of. The first things you check when you're on site or you go to a shop, you look at the Dow Corning 795. Is it expired? What is this?
Write down the lot number.
Yeah, of course. Did they use a rag and some, Kleenex or something to clean it off, or was it the two-tone method with the IPA? Now, being on the forensic side, I guess I'll say failures that you witness. I think about how much structurally glazed curtain wall that we have out there, probably in a city like Seattle or Philadelphia, Boston, New York, and how minimal or the level of quality control or sort of monitoring that was involved at that time in the 70s, in the 80s. Is there any part of you that's concerned about the existing building stock and the degradation over time? Are we going to see it degrading over like an accelerated rate? Part of what I initially wanted to talk to you about, and we can kind of go down this road or not, is the leaky condo crisis and how the market responded to that and how changes were made. But do you think some of these issues are going to sort of exasperate over time, or we're just improving the quality, as we go?
I think generally speaking, we're improving as we go. But we do fall victim into, the latest and greatest, the newest technology, and not sort of doing the necessary due diligence to get a level of comfort that it's actually going to work, right? And then every time something changes, every time there's a new code change, or every time there's a new product on the block, or a new supplier from somewhere else in the world that doesn't have the same level of internal QA, QC, processes, that's when we see these sort of catastrophic failures. And sometimes when I say catastrophic, it's not necessarily that somebody died, it's just millions and maybe even billions of dollars worth of losses because something didn't get thought through carefully enough. You brought up the leaky condo crisis, and that was just an example of a comedy of sort of errors in many respects, right? That's a building boom of wanting to bring a lot of urbanization to a downtown core in a wetter, damper climate, bringing an architectural style that isn't conducive to the climate, connected with a building trade group that didn't have the level of sophistication and knowledge on how to build things in a more exposed climate, right? When you're building tall buildings, the rain load, the wind load is just higher, right? And you can't get away with your building practices maybe that you used to get away with on 3-story buildings that maybe never really manifested because the wind and rain loads weren't that high, or they had sufficiently large overhangs that the water really never kind of hit those vulnerable details. And when you add all of those ingredients together, boom, you get this, this catastrophic problem that's happening. And then a lot of people had to step in and rectify the problem. But one of the biggest things that occurred was this loss of confidence in the design and construction industry, right? They started not believing that the engineers, the architects, and the contractors knew what they were doing, right? How could this happen at such a large scale? And that's really unfortunate. And then you got to do a lot of work to sort of bring that confidence level back and say, well, no, we actually know what the problem was, and there wasn't the right checks and balances in place to prevent those problems. And, then the lower mainland of BC started to get those checks and balances in place. And, Morrison Hershfield, RDH, JRS, all those kinds of companies were right there when all of this was sort of unraveling. And, they instituted having to have a building enclosure consultant on every project, right? And signing off on stuff and making sure that, this assembly was married to this assembly, which was a large part of the problem, or you were using the right assembly.
Do you think it was poor detailing, poor execution, or a little bit of all the above?
Oh, it was all of the above. I mean, they were using building assemblies that were inherently crappy, right? And then the detailing was crappy, the oversight was crappy, and there was just a lot of compounding factors that were just adding to it. I mean, I've told this story, I can't tell you how many times. People don't call, like 25, 30 years ago when I started, people didn't call us to work on buildings that worked. They called us to work on buildings that had problems, right?
Sure.
Right. So you become jaded and that every building sucks. And
Right.
It's like, well, they missed this. Okay, so maybe we'll hire you during construction to catch all the problems. And you'd get there and you're like, well, there's only so much I can do with what's already been designed without creating all these change orders. And then they would hire you to review the construction documents and you would, mark them up. But there's only so much you can do once they decided to use cast in place concrete.
Sure.
Right. And then slowly but surely our industry evolved and you started getting hired earlier in the process. So you could start actually informing them to use the right assemblies. And then you can get to the level of detailing, and then you can get to the level of construction oversight and the mock-ups and all that sort of stuff. But it starts with, stuff that's being decided at SD and maybe even earlier than schematic design, right?
So I heard you say something before, the sort of, you said a wet or damp climate, and I've heard that before, that taller buildings, wind-driven rains, but I want to push a little bit here, and we can dispute if we'd like, that I think New York, you have very tall buildings, very high wind loads, and corners of, you could get up to minus 86 PSF, extreme conditions in some of these high-rise buildings, and we have plenty of rain here. So when I went up to that market and got some feedback from the market, it seemed like the design community lived, died, everything, like embodied the whole rain screen principle. That was it. And could not get their head around a barrier system in the form of precast. And so you have a lot of that in New York. And are there leaks every now and then? Yes. Are there leaks every now and then on curtain wall buildings? Yes. So is that just a level of comfort with what's already existing in the market and a lack of familiarity?
Yeah, there is a ton of lack of familiarity. Well, if you want to talk about precast buildings, I probably got a couple of the tallest ones in the Seattle market under my belt are precast, right? The 500-foot Hyatt Hotel right in downtown Seattle is actually a precast sandwich panel. And the Braver and Signature Towers over in Bellevue are a couple of high-rise condominium projects that are precast, right? Because I came from Southern Ontario, I came from the East Coast, and I saw, precast can work. You just got to understand how to make it work with all the other systems, right? And how to advise owners of what the potential problems might be and how to have a plan for what those potential problems might be, et cetera, et cetera. So, back to the rain screen thing and the whole climate, New York, Seattle kind of thing. You're 100% right. We don't get any more total rain than Chicago, New York, Boston. It's all about the same. It's just different, right? We get a 6-month, 7-month sort of drizzle at about 35 to 45 degrees Fahrenheit, where New York, Boston will get large amounts of cloud bursts with periods of dryness in between, right? So building science is all about understanding, the building and how it interacts with the interior and exterior environment. So part of what I do is study the climate, study the wetting and drying potential of the climate and the damage mechanisms that it can occur when it gets wet. So, if it gets wet and it can dry, things don't deteriorate. But if they get wet and they stay wet for long periods of time at a temperature that is conducive to damage functions and degradation and rot mechanisms from occurring, that's where you can start getting problems. And that's why this climate is kind of harsh in some respects, is that the time periods of wetness coupled with temperatures that allow things to rot and degrade are fairly long, right? So the leaks here that might just be little drips that never actually even manifest to the interior, that raise the awareness that somebody's got to look on the outside like they would in New York when it's a big, huge cloud burst and it comes through and it's a big pool on the sill, makes somebody go out and check the sealants. Well, here they don't necessarily, but meanwhile, the thing is kind of deteriorating without them really even noticing. And that's kind of a little subtlety in the difference of how I think about the climates and how to detail things maybe a little bit differently. So,
I never thought about that, because I think I have heard feedback that on some of the most monumental buildings you could think of, existing buildings in New York, sometimes the building operator will have their mechanical engineer or chief engineer drop the pressure in the building, knowing a big storm is coming, because they're just used to, they know just because of the stack effect and that negative pressure, it's just going to draw in the water. And I think there's an understanding that droplets may make its way through at the interface in the wall, but ultimately it's going to dry itself out. It's not going to make its way through the sheetrock into the interior. But I never really thought about that. What you're saying is if you have that sustained rain for 3 months, all of a sudden that issue might start to compound.
So yeah, I got hired on I remember this forensic case. I got hired as a neutral expert because they just kind of agreed that they just wanted one person involved. High-rise curtain wall project, and there was known leaks. Like the unit owners would videotape and record the drip, right? And you knew which day it happened, and so it was a real thing that was really occurring. And we go out and drawing upon my personal water testing experience. I remember working with a young engineer, and we're out there testing it, and we're sort of incrementally ramping it up. This thing's not leaking. Go to 12 PSF, it's not leaking. 15 PSF, it's not leaking. And I said, okay, this is where we have to throw the standard in the garbage and say we need to figure out how to recreate a leak and then justify the testing approach after the fact, right? So I said, turn the pressure off and let it run. And sure enough, after a couple of hours, the water in an internal chamber had built up high enough to find the void, right? And we actually recreated the leak. Avoiding, ignoring the standard, but recreating it in exactly the way that it had manifested, right? That is forensic engineering at its core, right? Is really
100%.
thinking outside the box and saying, okay, now I know how to fix this building because I understand what the real problem is. And it's one of those things that when we look back at the dates that it was actually leaking, it wasn't a huge rainstorm. It wasn't a huge windstorm. It was 10 days of drizzle that led up to that it finally built up in the internal gutter enough to kick over some void in the sealant, right? Really, or a void in the gasket. And yeah, it's thinking differently about how things, leak and how things work and where the problems are and what the internal workings of this unitized curtain wall were and how that channeled water into a certain spot and figuring it out.
Let's say you establish there's an underlying issue. I can't remember who it was. I remember just seeing it was in a different city. A consultant made a recommendation list to a building owner, and he said, replace your gaskets, $3.5 million, whatever. Recaulk this, just replace the glass this, replace all the windows this, full reclad this. And the building owner saying this, why am I going to spend $15 million when I could remedy the problem for $3 million and it'll buy me another 8 years or 10 years? And I guess this is a short-sighted question. I was going to say, do you think these Band-Aid approaches work? That's way too broad of a question. A better question would be, do you think some of these buildings are so far gone in terms of like ease of maintenance or repair that there's no alternate means other than to just kind of rip out and start over?
There's probably a sliver of buildings out there that I would say fit into that category, that it doesn't make a lot of sense. But at the end of the day, as a consultant, you can't lose sight of the fact of trying to understand your client and their needs and what their goals are for the building, right? And really trying to understand, you know, are they trying to sell this in 1 year? Are they going to hold it forever and ever? And trying to give them the best information to make the most informed decision that they can. Because at the end of the day, you know, unless it's a code thing where they've red tagged the building and they have to do something, it's up to them. And you're a way of sharing experience and knowledge of saying, this is your width of options, and these are the likely outcomes of each one of these choices, right? You can do A, but don't be surprised when this happens. And if you're okay with that, hey, spend the 25,000 bucks and deal with the one leak, you know, a couple of times a year. Or if you want to set it and forget it and not have to worry about this because you're worried about somebody suing you, it's going to be the $1 million option. And yet this is going to solve all the problems, and you're not going to have all these other issues going along with it. And you know, there's usually a couple of options in between, and they're the ones that have to make the ultimate decision, and they got to trust that you're giving them good advice.
All right, Rob, this was a lot of fun. I do want you to come back on. I need to spend a little bit of time on who I think would be good to have you on to do a healthy debate with, because I think you can you could certainly hold your own. But until then, I know you're active on LinkedIn. What would be a great way for people if they do want any forensic help or aid on the consulting side? What would be the best way to reach you?
Rob at bombinoconsulting.com. So BOMBINO. LinkedIn is a good way, and I'll even give my phone number out. You can call me at 206-920-6782. Always happy to help. It's one of the things that I consider enjoyable in this world, is to actually help figure things out and help keep people out of trouble. So whatever I can do to help, feel free to give a call or shoot me an email.
Awesome. Thanks for hopping on, Rob. A lot of fun.
No problem. I appreciate the opportunity to chat with you. It was nice participating.
Of course.
Take care.